So, good afternoon. We're going to deal with scientific notation. We're going to do some examples with that. Maybe I think you've got a couple applications involved with scientific notation. So, we've got some things to do here. I do want to recall a couple things that we've done in the past. Some pre-algebra stuff here that we kind of did. Remember 200 times 300. One of the things we picked up on is we said these zeros represent multiplying by 10. So we understand this is like 2 times 10 times 10. And then we're multiplying this by 300, which also means 3 times 10 times 10. So remember, each zero represents multiplying by 10. And remember, multiplying by 10 basically means you're increasing your place value by one spot. So what I learned is, this really is the same thing as 2 times 3 times 10 times 10 times 10 times 10. Because remember, multiplication is commutative, I can change the order. So what it boiled down to was 2 times 3 was 6. And each time we saw multiplying by 10, we multiplying by 10 as adding a 0. So this simply said add a 0, add a 0, add a 0, add a 0. So it needs to add in 4 zeros. So therefore our answer was 60,000. But also picked up on that, 10 times 10 times 10 times 10 could also mean the same thing as 6 times 10 to the 4th power. So there's a couple ways I could express that. Early on we were saying, hey, let's write that 60,000. But there's also a thing of 6 times 10 to the 4th. That's considered scientific notation. Scientific notation has the form of a times 10 to the nth power. This a, this first part, has to be a number between 1 and 10. So this is what this is mean. A has to be greater than or equal to 1, but it has to be less than 10. So that a has to be a number that can be 1, but it cannot be 10. It has to be smaller than 10. So it's got to be a number basically between 1 and 10, essentially here. Now n has to be an integer. So what that's saying is n has to be a positive or a negative number, like 0, 1, 2, 3, 4, so forth and so on. But also that n could be a negative 1, or a negative 2, or a negative 3, or a negative 4. It can be what we call integers, those positive and negative numbers. So 6 times 10 to the 4th actually meets this criteria. The 6 is between 1 and 10, and 4 is a positive integer. So 6 times 10 to the 4th, that actually is a scientific notation. And this would be just expanded out. Now if I look at 2.3 times 0.04, 2 3/10 times 400ths. Remember we said we can change this to 23 divided by 10. Because remember, divided by 10 means lose a place value, so that changes it back to 2.3. And we're multiplying, we can also change that to 4 divided by 10 divided by 10. Notice how each time I divide by 10, that means to slide the decimal over to place values. So 4 divided by 10 divided by 10 is the same thing as 400ths. So what I can do is change this to 23 times 4, divide by 10, divide by 10, divide by 10. We're also picking up on dividing by 10 really means multiplying by 1/10. So this also means 23 times 4, and then I could say times 1/10 times 1/10 times 1/10. So we learned that to do this math, all you really got to do is go 23 times 4. 23 times 4 would be 92. And then each time you multiply by 1/10, multiplying by 1/10 means you lose your place value 3 times. So that means your decimal was here. It's now got to slide over. From here, it's got to slide over 3 spots. 1, 2, 3. So you end up with this, I got to hold that place value, so it's going to be 0.092. So we learned that with multiplying decimals, you ignored the decimal, did the whole number math, and then since we had 3 numbers behind the decimal, I had to slide that decimal over 3 spots, and that gave me this 0.092. But also pick up on that 1/10 is the same thing as 10 to the negative 1. So remember, negative exponents are there. 10 negative 1 means to flip it and make it a 1/10. So what I also see is I have 92 times 10 to the negative 1 times 10 to the negative 1 times 10 to the negative 1, which means I have 92 times 10 to the negative 3. Because we know that when you have the same base, you're allowed to add those exponents. So a negative 1, a negative 1, and a negative 1 makes that a negative 3. So I can change it to 92 times 10 to the negative 3. So notice that 10 to the negative 3 basically means you're dividing by 10 3 times. So in other words, you're losing 3 place values. But notice that this is not in scientific notation because the A has to be between 1 and 10. So I'd actually have to change it to 9.2 times 10 times 10 to the negative 3. Notice that I lost the place value, so I have to multiply by 10 because that would move the decimal back out that way. So 9.2 times 10 is really the same thing as 92. So since I lost a place value, I had to multiply by 10 to put that place value back in. And we do know that 10 to the first times 10 to the negative 2, that becomes then 9.2 times 10 to the negative 2. 9.2 times 10 to the negative 2, that would be what we would call scientific notation. And again, notice that 10 to the negative 2 means to divide by 2 tens. In other words, move your decimal 2 places to the left. And if I move my decimal 2 places to the left, that does indeed give me my 0.92. 0.092. So 92 thousandths would be the answer. Okay? So that's some food for thought. We've been kind of playing around with some numbers that are really closely tied into scientific notation. Okay? Let me clean this off a little bit. I want to do this guy right over here. That got to be a little bit busy. So, something else that we did is we did something like this. We expanded it out. We broke it apart. So, if we look at this problem right here, 25,378 and 914 thousandths. Remember, we can look at this by place value. So we have the 2 would be in the 10 thousandths place, that's 20,000, plus then 5,000, plus then 300, plus then 70, plus 8, plus then 9 tenths, plus 1/100th, plus 4 thousandths. Now, we can come back through and say, well, that is 2 times 10,000. Plus, that's 5 times 1,000. Plus then, I'm going to go ahead and put those in parentheses. Show up a little bit better. 300 would be 3 times 100. 70 would be 7 times 10. Looks like I got a wet spot there. Hold on here. So I can drive a marker back out here. So that's going to be 7 times 10 for 70, plus then 8 times 1. Since that's in the ones place, that's 8 ones. Plus then that's going to be 9 times a tenth. Plus that's going to be 1 times 100. And that's going to be 4 times 1,000. I'm going to come back here and I'm going to change these to fractions. That may make a little better sense to us. So 9 times 1/10, I can write that as a fraction. 1 times 100th, and then 4 times 1,000. It may look better as a fractional notation there. Now notice that 10,000 really is the same thing as 4 tens. Remember, each time you see a 0, that means you're multiplying by 10. So what I could do is change that to 2 times 10 to the 4th power. I can use what we would call a scientific notation with that. Plus then 5 times 10 to the 3rd. Notice how again you got 3 zeros there, so that's 10 to the 3rd. You have then 3 times 10 squared. Plus then 7 times 10 to the 1st, so that's still the same thing. 7 times 10 to the 1st. I'm going to put that 1 there. Plus then 8 times, you kind of pick up on my theme here. 10 to the 4th, 10 to the 3rd, 10 squared, 10 to the 1st. So that means I want to put 10 to the what power. 10 to the what power is going to represent a 1. Well, we know that's got to be 10 to the 0. That's going to represent our 1. Then I can have 9 times 10 to, well, remember to make a 1/10, I need a negative exponent. So that's going to be 10 to the negative 1. So 10 to the negative 1 is the same thing as 1/10, or you're dividing by 10. You have 1 times 10 to the negative 2, because 10 to the negative 2 is going to be the same thing as 100th. And you can change that then to 4 times 10 to the negative 3. I can do that. So we actually can use scientific notation as a way to expand out a number. You know, before we did like this, we may have even done this. I think I may have even talked about this. But this is, again, a form of scientific notation. So it's out there. We use it in various ways. But mainly what we use scientific notation for is when we get into really, really big numbers. We don't want to type those big numbers into a calculator. And practically, I mean, some calculators you can't even put those numbers in because there's not enough space there. So we have to use a different notation to do that. So that's where we're going to go with this and see if we can kind of pick up on